Are you ready to ace your next technical programming interview? In this video, Keith Galley conducts a mock, full-length, real-world coding technical interview with Kylie Ying for a software engineering role. Learn how to use object-oriented programming and dynamic programming to solve questions and get the job you want.
Most people would probably agree that one of the worst parts about finding a job as a software engineer is the technical interview. During these programming related interviews, the interviewer will expect you to work to a solution, optimize it, and write code or pseudocode on the spot. The reasoning behind these interviews is that they will help the interviewer understand your ability to understand the problem, ask questions, go deeper, and optimize the solution. How much do you understand data structures and algorithms? And ultimately, what is your coding level and what is your coding ability? Today, I paired up with a good friend of mine, Keith Galley, who has a data science focused YouTube channel, and he is going to be mock interviewing me. So this interview might look like what a real software engineering interview looks like. I don't know what question he's gonna ask, so it's gonna be as much of a surprise to me as it is to you. And I will be coding on the spot, so here we go.
Welcome. Welcome to the interview. How are you doing today?
I'm good. How are you?
I'm doing pretty well. We're going to probably just jump right into this interview. I'm just curious, are you familiar with CoderPad? Because that's what we're going to be using throughout. I think it might be easiest to kind of share code.
Yeah.
Cool. All right, so we're going to kind of just jump right into the problem. So for the purpose of this problem, and let me share, I just want to make sure you can access this coder link. So I'm going to share this, and I recommend maybe sharing your screen, or I guess we also can just work off of this. So I should be able to see what you type in.
If I open the chat, I can click on this link, and it'll take me to the CoderPad. My name is Kylie, and I will enter. And so I can see that you're in this CoderPad as well, and then here I am.
Yep, and
Okay,
just to
awesome.
make sure that you're comfortable here, you want to just run like a couple simple lines of code. You can try just running this print hello world if you want.
Yeah, so if I run this, it'll say that I ran a line of Python, it prints out hello world, so I think it works.
Perfect. Okay, so let's kind of jump into the problem. So just to give you some context, we're going to start with about 20 minutes of design, object-oriented design, however you want to design this code. And then we'll spend probably the last 20 minutes working on more of an algorithms question. So that gives you just a little bit of scope.
Awesome.
You don't necessarily have to accomplish everything. You know, I know that we have limited time. But to kind of give you the context of the problem, imagine that we're designing a book system, so an online cloud reading application. And you can pretty much imagine that we're building a product that is similar to an Amazon Kindle, but specifically for short stories. So we're kind of in our own niche. They might be indie stories. They might not be, found anywhere else. People could add their own stories. And basically what we want to do to start this problem off is that we need help designing the actual application. We need help designing the code that could implement an online cloud reading application. And there's a couple things that we're looking for. And this is very open-ended. You can implement this how you want. But a few things, and I'll paste these into the CoderPad that we're looking for. I'll just paste it below.
Yeah.
OK. You can fix this up. And I'll delete that top line.
Okay, so a few things that you're looking for. Users have a library of books that they can add to or remove from. Users can set a book from their library as active. The reading application remembers where a user left off in a given book, and the reading application only displays a page of text at a time in the active book.
Exactly.
Okay. Awesome. So let's see. essentially what we want to do is create a library where users can interact with this library. They can look at a book and set it as active, and then this application will also just remember where they left off and display whatever page that they're currently looking at in the active book.
Exactly.
Is that correct? Okay.
Correct.
Okay, and then more specifically, do you want me to kind of give like a high-level implementation, or how do you want me to start this?
So I really want to just think about, what components would be important. This is, I would say, an object-oriented design question. So I'm just thinking about how you would think about structuring, I guess, the base of a program like this. So obviously, we're not going to build this full application, but I'm really curious
Right.
about how you're structuring that core structure, that core foundation.
Right, so let me make this smaller over on this end so people can see all of this. And let's type up some more notes. So the things that jump out to me are that you need to be able to remember all books. So if I type this, we need to have all books in the library, and we need to remember active book. And then we want to remember page, I guess, last pages in all books. And then we want to display a page in active book. Okay, so by this all books in the library, is that more so, I guess, how are we representing these books? Are they just like strings? Do they have a page number and then the string of text? How is that formatted? Is it like HTML?
I think it's up to you how you want to store the books within like this programming structure. So you can kind of decide what makes sense for that. I think the important things is the actual text of the book, as well as the title of the book.
Okay.
And you can implement
so-
the details of like the pages and all of that.
Yeah. Okay, so I think that there's two things that jump out to me here, right? We need one class. We want one class representing a book, and then we want another class perhaps representing a library, so a collection of books. And so in this book specifically, you just mentioned that we want the title as well as the like pages in the book.
Yep.
Or like I could rename that the content
Yep. Exactly.
in the book. And then for the library, we have a collection of books. And then I would also argue that this page, that whatever the active book is would be at the library level, because we just want to toggle which one is active amongst this entire group, right?
Yep.
And then actually, so this last page in the book, I think I'm going to put that under the book because it's book specific. So I
Yep.
think it would make sense for every single book to just remember the last page. So user looked at. Okay, so I like how this is represented. And then I think kind of diving more so into the implementation, I think for the title, a string would make sense here because, I mean, a title is just a string.
Yep.
The pages and the content in the book. So the things here are, the pages are ordered, right? When you go through a book, they're ordered, and there's a specific amount of content per page. And so I think something that would make sense for this is just a list, because I think a list is ordered. It's a collection of items, and we can't, I mean, I think like a set, you would lose the ordering. A dictionary, you would lose the ordering, and you would also overcomplicate things a little bit. You could have the page numbers as the keys, but then a list would also do the same thing, but kind of in a more elegant manner. And then finally, a tuple. Okay, you could also have a tuple, but I don't think there's a reason to use like a tuple over a list in this specific example.
Yep.
Or like vice versa. Like I think that you could choose from either one. So I think here I'm just gonna use a list of, I guess, strings, which represent per page. So like each string represents whatever's on an entire page. And then the last page that the user looked at, this would just be some integer, and this would be an index into this list of strings. So I would have to remember that this, you know, there might be an off by 1 error here, because in Python we start at 0, but like naturally when we're reading a book, we might start at 1.
Yep.
Now for this library, for this collection of books, okay, well, so for this active book, you could either use a Boolean where you set one book to active and the rest to inactive. But I think that would be kind of excessive because every single time we toggle a book as active, we have to toggle everything else as inactive, right? You can't have 2 active books.
Yeah.
Okay.
Yeah, that makes sense.
Okay, so then I think in that case, instead, what I would rather do is have some sort of a string or some sort of like an ID matching system where we have like one variable that's set to the active book, and that might be the title or the ID of a certain book in the library. So maybe we can just add ID here. And maybe I can make that also a string or an integer or something.
Yep.
And I'm gonna add a question mark to kind of just say like, maybe we could implement that, but I'm not sure if we'd want to right now. So this would correspond to ID. So this would just be some variable. And then this collection of books, so I guess like when we display this page in an active book, I think that this might have an advantage being like some sort of a lookup table because we have a certain sense of an ID, right? And I think what could make sense here is having the ID correspond to the book object that we define up here. So this could be a book object, right? And so we don't really need this ID. I think that if all the titles are unique, then we don't need this ID. We can just use the titles as the IDs. But in some cases, in the real world, not all titles are unique, and so that's when an ID might come in handy. And so I'll leave that, like, what are our assumptions here? Can we assume that the titles are unique, or should I be using this ID structure?
I think I like the ID structure because, we're not necessarily going to know that everything's unique, so I think this is a little bit more robust.
Okay, awesome. So I think this representation looks good to me, so I'm just going to go through the requirements again. Just to make sure that I've covered all my bases. So here I want all books. Okay, so I want a library of books that I can add to or remove from. And so here I have a library, and anytime I want to add to this library, I can just add an ID. I can add the book. If I want to remove from the library, then I can just simply delete the key item pair or the key whatever pair, key value pair. I can set a book from their library as active, and so here I have this active book, and we could always say, like, if there is no active book, then we set this to none or something like that. The reading application remembers where a user left off, so we have that here, right? The last page that the user looked at, and not just in the active book. And then displaying one page of text at a time in the active book. So we have the active book, we can get the book object from that, and then we can go to the page that the user last looked at by indexing this value into this list. So I think we've covered all the bases here.
Cool. Let's do a couple things. I think as a starting point, and this doesn't have to get too crazy, but I would love to just see some, Python pseudocode or even some Python kind of code, just to like maybe flesh out one of these classes. I just want to, look at that a little bit and how you would actually start writing this code.
Yeah, sure. So for example, here let's start with the book. And when we define a class, let's initialize this. So when we initialize a book, we definitely should pass in the title and then the content, right? I'm assuming that when we add a book, these things have to be given to us. And then I'm assuming that when we add a book, we don't have a last page that the user has looked at. Is that an okay assumption?
Yeah, I like that assumption.
Okay. So we can set the title of this book just equal to whatever the title is, the content of this book. And I'm going to assume that these are given to us in the formatting that we want. So the title is a string and the content is a list of strings that correspond to the pages. And I'm going to create a variable last page, and I'm going to set that equal to just 0. I could also probably set it equal to -1 or something, but I think 0 makes sense because that would be the beginning, right?
Yep.
And then we need to come up with some sort of an ID. So typically, maybe we would have some sort of function that takes in the title and the content, or maybe the author or something, and like returns a unique ID. But I think maybe something that we can do here just very simply is have some sort of counter in the library, and then every single time we like add a new book, we can just associate that counter with that book, and so then we know that they're all unique and they all have their own IDs. Would that make sense?
Yeah, that makes sense.
Okay, so then I would have to pass in the ID. Yeah. And so what I'm actually going to do is self.id equals ID. And then, yeah, and so then, for example, we might want like a display page, right, in this book. And so for that, then we just want to return whatever is at the last page of the content.
And I guess let's build on this a little bit. Another useful function, obviously you want to start at the last page, but let's say we're starting to turn the page. What might that look like?
Right, and so if we're turning the page, then all we want to do is increment the last page, right? And so we might do self.lastPage, and we just increment that by 1. And then we could call display page after that. If we assume that, like, we could, if we assume that these two go together. So if we assume that when we turn the page, we want to display that page, then I would just return display page.
Yep.
Like that. And then actually, I'm just going to go ahead and code up this library as well. So this library, we have this collection of books and then also the active book. So rather than initializing a library with books, I think let's just add them to this. So initially, this collection might just be an empty dictionary, and then the active book might be none, right? So then when we want to add stuff, so add to collection, book, what I'm going to do, so there's either the user could like, or our API could like return a book with the title and the content, etc. But since we said that we would pass the ID through like the library because we might have like a counter, like some sort of ID counter. I mean, this is not the best way to do it, but I think this is like a fine hack for right now. Just to make all the IDs unique. What we can do here is we can also, when we want to add a book, just pass in the title and the content. And so then our new book is going to be a book, as we've defined above, with the ID and the title and the count or the content. And then after we create this new book, we want to increment the ID counter. And then we also want to add this new book into the collection, right? So I'm going to add self.collection, and I'm going to make the ID, whatever the ID of the book is. So actually, I'm just going to call new book.id because I think that's a bit cleaner. And this is going to be the new book. And then we increment the counter by 1. So this is us adding to the collection. So of course we want to remove from the collection. And so we said that we wanted to remove based on the ID. So all we have to do is, I think there's this delete in Python.
I'm not sure if there is.
I don't remember. Do you know, Keith? Okay. Is there a remove? Let's see.
I think that there's, I mean, it should autocomplete here in the coder pad.
Oh, isn't it del? Isn't there a del?
I mean, I think the biggest thing is it going to be
valid.
happening in place, or is it going to be happening in creating a copy? I understand.
Yeah, so we want it in place from
Yeah.
the collection.
I understand what you're trying to do.
Yeah.
So the exact details is
yeah.
not super important to me.
Okay. Yeah, so anyways, this is removing from the collection. And when we set active book, again, we want to do this based on the ID. So I'm going to make self.activeBook equal to whatever that ID is. And let's see. So the user has a library of books they can add or remove from. We did that. Setting a book as active. Okay, and then remembering where a user left off. So we've actually taken care of that already implicitly in our book class. And then the reading application only displays a page of text at a time. All right, so then here we can say define display page. And actually we don't even need the ID of the book because we already have the active book ID. Right, and so what I'm going to do is I'm going to go into my collection and I'm going to get the active book like this. So,
Yep.
blah, blah, and I'm going to click, or I'm going to do dot display page. And then of course we also have this turn page that I could just code up as well.
Yep.
So you get the idea, but so we want to, turn that page. I do think that some like drawbacks here are that, okay, so one thing that we could have done is instead of this active book, instead of saving the ID, we could have saved the book itself. And I think from a Pythonic standpoint, that might make sense. But then in the future, if we're using some sort of database or something, an ID would make more sense because that's easier to store in like a table. And if, and okay, also for this display page, you might see that we've called this display page and turn page up here in the book. And the reason why I did that rather than just call like self.book.content last page, like book.last page or something, was because I think that, like, for example, this should be independent of how we implement the book, right? So we want to keep those as kind of separate blocks as possible. And so here, what this allows me to do is when I go back to my book, like if I decide to scrap this implementation, implement something else, I know that I would just have to implement the methods display page and turn page for that to work. And like these functions should work.
This looks good to me. I like the start. I think that this definitely lays out the foundation of what I was looking for with the requirements of this application. So nice work with this. Couple quick follow-up questions before we kind of branch into more of an algorithms type question as the follow-up here. One question is, let's say you have an older reader and their vision isn't as great, so they need to make the size of the font bigger. So kind of keeping that in mind, that you might have this variable font size, how might you, refactor or change or modify your current structure? And you don't have to actually write code here. Let's just discuss this to account for that increase in size.
Yeah. Yeah, so when we increase something in size, like I'm just thinking about intuitively on our like phone screens or something, that tends to shift the content, right? So like some page that might hold 100 words or 100 characters at, a small font size might only hold 50 when we double that font size. So for the book, instead of having this list, what I might do is I might just save the entire book as a string, so I would, let me just edit this in here because I think it's easier to visualize what I'm saying. But so I might have like a font size equal to, I guess we could just use like the traditional like 12-point font or like whatever. But when we have this font size, we could come up with some sort of characters per page calculation, right? And so that would be based off the font size. So calculate. So this is going to be pseudocode now. This calculate doesn't actually exist, but calculate based on that font size. And I'm commenting it out so it doesn't have any errors. But then when we do calculate that, then what we can do in order to get this display page thing would be, instead of indexing into this content, which is now just a long string of characters, what we can do here is we can return, we would have to do some sort of calculation, right? So we would need to, we have this characters per page, and we can multiply that by whatever the last page is. And so this would give us like kind of the starting index of this long string of characters to start the content of that page. Start index would be this. And then what we would want to do is then return the self.content from that start index until the start index plus the number of characters on that page. So that would be our end index. So actually, let me just write that out to make things a little bit more clear. So now, essentially what I've done is we have this variable font size, which we can calculate characters per page, depending on that font size. So that might be more characters or less characters, depending on how big the font size is. And then our content, instead of a list of strings, is now just a really long string of characters. And I guess some assumptions that I'm making here are that this would just be approximate. So for example, if we had a \n, which is like a line break, right? That might just end up counting as a character or two characters. But the assumption is that that would be approximate per page, or maybe that we're using some sort of like monospaced font or something like that. But essentially, now that we have the characters per page and then just a long string of characters that represents the content, we can index into that content depending on, like, based on the last page that we know. And so what's really cool here is that when we do turn the page, we can just end up calling this. So this is kind of that granularity that I was talking about.
Yeah, that makes a lot of sense to me. And definitely you see the advantage of having that function that you can change by having to implement something different.
Right.
One last quick, I guess, follow-up, and then we'll move on to the algorithms portion of this interview. I'm just trying to think, at a high level, let's say that we had multiple users in this system, and they all shared books. So like, they might all share the Harry Potter books or something like that. Like, books are common among all of them. How might you modify this, given that, some of these qualities of a book might be shared between users because they're all trying to access that same book. Does that make sense?
Yeah, so yeah, for sure. So I think that when we start to, have like multiple people involved, like these books might get stored somewhere, for example, in like a SQL table, right? And so then when that happens, we would still want to maybe store like the ID, the title, the content in that table. Now, the only changes would be that these sort of customizations are per user. But the book and the content, those are for this entire group of people. And what we can do, I think, is instead of this ID counter being like library specific, we can start identifying books by their IDs on a more like global scale, right? And so, this was kind of just a hack to make this ID thing work and be independent and be like unique. But for example, when you put something into a SQL table, you can also have an ID associated with those entries. And so maybe when we add to the collection, if we see that the title and the content is already in the table, then we instead just return the book that's already in that table or something like that.
Yeah, okay. I think that makes sense to me. Cool. I'm happy with this discussion. I think that we can move on to the second portion. I guess, do you have any, last questions on this before I move on? Or last things you want to say?
Yeah, so no last questions. I think that the last thing I want to say is also like it would really depend on like how you implement this like group of people, right? Like, so my immediate thought was like a SQL table, but that doesn't have to be the only way. So yeah, I think.
Okay, cool.
I think it would depend on that.
All right, awesome. Let's switch gears, and I'm probably going to just comment this out in case you do want to run some code and there's any errors or issues in this. So I'm just going to comment this out, but I'm going to leave it here just so we have it to look back at. And I'm going to just indent this a bunch, and we're going to just start at the top of the screen. So don't mind all the stuff at the bottom. All right, so another important component of our book reading system, and this is completely independent, you don't have to reference any of your past code, is I mentioned this is for short stories, and you could have independent indie authors, adding these short stories. So they're not going to be, the classics. They're not going to be those types of titles. They're probably going to be smaller authors. So one thing that we want to avoid in this system is plagiarism. So my task for you is to design an algorithm that would be able to detect the two most likely books that would have plagiarism in them. So like the two most likely books that pop up as a match for potential plagiarism in a library. And we can define most likely as meaning they have the longest shared common section of text. So we have a library of books, and we're looking for the two that have the longest shared common section of text. And we specifically might want to know how many characters that section of text is. So you can imagine if it's sharing a single word, obviously not an issue, but if it's sharing 6 paragraphs, that's going to be a problem. So does that make sense?
Right. So just to clarify some things, what Keith really means here by substring is that, for example, if I have a string such as learning, what are substrings of this? Well, one possible substring is learn. Another possible is earn, because these are strings that are using characters that belong to this string, learning. Another possible one is earning. Oops. Now you might say, okay, Kylie, all of these are consecutive in terms of the characters. So here, all of these correspond as characters that are next to each other. But in this specific example, Keith is not actually asking, okay, it has to be a consecutive substring. Instead, what Keith is asking is just any substring, which means that as long as the letters are in the correct sequence, you can skip characters if you want to. So for example, here, leg would actually also be a substring. Or an. So for example, right here, we have earn as a substring of consecutive characters, but down here, I could rewrite it as a substring where there's actually a gap of 2 characters in the middle, but this would still be a valid substring. So it doesn't have to be consecutive, we just need all the characters to be in order from left to right. Let's see, let's start off with kind of a naive solution for that. Well, one thing that you could do is literally come up with every single combination of like substrings for both of these, and then compare those and see which 2 substrings are the longest, right? But there's a lot of different combinations for substrings, and so I think that we should come up with a more elegant solution. Let's see. So one thing that I'm thinking is we should have pointers that start at the beginning of both strings and kind of move along until one of them detects a shared character. So, or like until one of them detects like the first shared character. So here actually, like I would say the first shared character is H. Right? And so here we would have like the 2 pointers kind of be this. Maybe I'll go from the bottom. But here and here, right? And so we look at the next character and we realize, okay, they're not the same, so then we want to keep going. But one downside of this is that, well, okay, what if I want to start comparing from here and here, right? Okay, and then I move it over and like these 2 have like 2 shared characters. So I think that there's still this question of there's a lot of different combinations here. So
I think you're on the right track though. I like this.
And then
these
okay,
thoughts
so like,
far.
Yeah. Okay. Yeah, so I know that here I want kind of these pointers that are moving and then I just want to be able to align them. Right? I think that's the key here is this alignment. And so now I think we just have to figure out how to make that alignment work. I'm kind of thinking like one thing that we could do is kind of have more of a base sentence and then one where when we have like, so for example, if I made this my base sentence, then in the other sentence, I would want to search this sentence for each character. So if I have the I here, then like my first, I would start looking from here, and then maybe I would start to look from here. Right. But I think that would end up also being kind of long because for every single character in here, you would have to iterate through this entire thing and do the whole matching process. And so does that make sense why that's like maybe not the most optimal solution?
Yeah, that makes sense. And I guess what would be the runtime of that?
It would be O of n squared because, well, I guess if we have one sentence O of n and one sentence O of m, it would be O of nm. Because for every single character, we have to run through the other string m times. And actually, okay, so like if my base sentence is like what is the worst thing that can happen is like a base sentence like this, right? And then you're searching. The worst case example would be like something like this, right? Where like if I have an I, well, I have to go through each of these. And so, yeah, I guess we would have to go through until, like, they don't match anymore. But then that would just be the very end of this. So, like, maybe I can add, like, an A at the end of that. So then I would actually... Okay, so then I would say it might be O of n squared m, where n is the
I think that makes sense to me.
I think that we should come up with a different solution. I'm trying to think of how dynamic programming would work, because I do think that this might be a dynamic programming problem. I'm not sure of how to formulate it.
Yeah. Let's I think that you're onto something here. I think I'm trying to think of good ways to kind of kick you off here. I mean, I would say let's just let's assume that this is dynamic programming. I think as a good starting point, maybe we can talk about subproblems here and try to define that, and maybe that will help us get to our solution. Or also maybe just define a base case, and maybe that will help us get to the solution. So I think let's assume that dynamic programming can be used here. Yeah. Let's maybe just start trying to figure out subproblems and maybe a base case.
Yeah. Yeah, so I definitely think that the base case would be pretty simple, and it would just be if there is a match, right, between the two, like if the two sentences equal another, that would be, okay, let's think about all the possible base cases. So it'd be if there's a match, or maybe we've iterated through everything that we can, and we're comparing like an empty string to non-empty, or even empty to empty, which is when we would know that we're at the very end, right? Yeah, so for example, with this match, I mean by like read to read, like that would be an exact match. So I think the difficulty of this problem is that we can start anywhere in the texts, right? And I guess if we were trying to recurse through this, or if we were trying to go through this with dynamic programming, what I would kind of want to do is say, okay, either like S is the start of some substring in this sentence, or it's not, right? And if it's not, then we want to move over and we want to say, okay, well then is like H is a substring, or the start of a substring from this other sentence, or it's not. And we want to kind of continue that process. And so if, for example, H is a substring, then we would want to figure out what the longest matching one is, and then that would essentially like skip us over a few blocks. And so I think another way to kind of formulate this might actually be like how many characters can kind of almost subtract from the two. And
I might jump in here. I think you're on the right track, but I might provide a little bit maybe of more of a launching point, just because I want to be considerate of our time here. I think you're on the right track. I think that let's maybe try to define this like with a single line expression, like a single line recurrence type expression. Because I think that if we can build up subproblems to that final state, that will help us. So let's say we have sections of text A, and I'll put this in quotes here. We have A is one of our sections of text, and B is another one of our sections of text. And basically, that could be hello world or something, and world, just world or something like that. We can assume that basically what we could start doing here is we can imagine that we wanted to find the longest match between A and B. And you could define that as from character index 0 to character index 0 here. So like the longest common subsequence here or substring of A, B, 0, 0 would be our kind of goal state, because we would want to find, if we're working backwards, let's say, we want to find all the way to the beginning. But to help us get there, we could probably see if, what is the longest substring at different indexes. So if, maybe index 3, index 5, so like this would be the, I guess, last character, 5 would be like the last character of B. And I guess keeping this in mind, can we define this in such a way where we can define an equation that would help us work up to that final goal, which would be the entire sequence?
Okay, so if we're using kind of these A-B strings as example, let's define some like find longest substring or something. And we might have string A, string B, right? So, and you're saying, okay, let's do index A and index B as well and start those off with 0. That would be our recurrence relation. And so I guess what we'd want to do is find the longest substring between these. And we want to increment one or the other. Right. So like that. Or if string A equals string B, then what we'd want to do is find the longest substring. We want to increment both of these indices, apparently. Oops, sorry. So I meant string A at index A and string B at index B, like this. So then we'd want to increment both of the indices, and we want to add 1, right? Because this means that we've found a starting match. And what we want to do is actually take so here,
and if you want to just write pseudocode here, it's fine too, for me.
Possibility.
Okay, that makes sense to me.
Yeah, so let's just do all these possibilities, and so then if the 2, then we have this like third possibility, right? And what I would want to do is take kind of the minimum. Why is this giving me an error? Oh, so then I would want to return the max of possibility 1, possibility 2. Okay, let's write pseudocode. Possibility 1, possibility 2, and then possibility 3. Only if
this makes sense to me.
If applicable. And then with our base case, we said that it would be if one of them is at the end. So let me add that in here. So maybe like if IDX A is equal to the length of string A, then we want to return 0. Or in here, or IDX B is equal to the length of string B. Yeah, so then for our longest substring, this makes sense now because with each index, we have the possibility of shifting it over 1 and trying to compare this sentence with this entire one, or shifting the other one over 1, comparing those two indices or those two substrings from there on. Or if they are a match, then we also have the third option of moving both of them over. So actually I should go from here. And then because this find longest substring repeats all of that on the next character for those two, then we repeat that process again and we add 1 every single time to that. So I think logically this makes sense. Now, one thing might also be that we start to kind of recurse a lot on the same indices,
Yep.
right? Because we're trying all these different combinations, and if we move them both over by 1, then we kind of are iterating over through them a lot. So I think that one thing that we could also do is implement some sort of memoization. So here, like maybe, hold on, I lost the, here we go. Okay, so then, like, if the memoization is none, then we might want to start this with some sort of, it could be a dictionary. I think that also what could make sense is like a list of lists, right? So like maybe -1 because there's no such thing as a -1 length substring. And I'm gonna multiply that by the length of like string A, for example.
Yep.
And then this whole thing by the length of string B. And so essentially I have this table of
Yeah,
it would be
I
string A
understand.
this way and then string B down.
I always get confused with the direction of these things, but I understand the goal of this length string A and length string B. Basically create a table that stores some of these values.
Yeah. Exactly.
Yeah.
Yeah, and then in order to store that here, then we would want to create like the index A, index B. These might be backwards, but we would want to store that essentially. And so then we'd want to add a case of like if like this memo at index A, index B, these might be backwards again. If that's -1, then we want to return, if that's not -1, then that means that we've already found the answer, so then we just want to return whatever we've memorized there. Cool. And so then at the very end, we'd want to just return memo like that. And let me just think about these indices quickly. So the first one is string B. So actually, if I just swap these two, that should make it work. Because first we'd index into A and then we'd index into B.
Yep.
So yeah, if I just swap those two, that would work.
Cool. Yeah, this makes sense to me.
So,
I guess my last question, I think that this is the approach that I was kind of thinking about as far as dynamic programming goes. My last question is, what would be the runtime of this, memoized dynamic programming solution?
Okay, so here we are going through all of index A, or all of string A and all of string B, right, by incrementing these indices until we hit a base case. So there's no way to avoid going through both of them, and incrementing one but not the other. And so we essentially have to fill out this entire memoization table in order to figure out our answer, right?
Yep.
Which means that it would be O of N of N.
And then my last question, I know we're running right up on time, is, I guess given the context of the original problem was you might have a library of books, how would you leverage this find longest substring to, I guess, find the two most, like the highest probability matches in the entire library of books?
I think that, so here, now that we have this find the longest substring with string A, string B, and let's suppose that we changed the implementation of this book to be this like long string of characters for the content. then that means that what we can do for this find longest substring is just pass in like book A dot content and book B dot content and figure out the longest substring between the two of them. And we can do that for all the combinations of books, unique combinations of books. And if we find, for example, okay, well, so the prompt is to detect the 2 most likely books that have plagiarism.
Yep.
So we would just return the 2 books with the longest substring. But, you know, maybe we want to say like any books where more than 30% of the more than 30% of the book is, or maybe even like 10%, shares the same substring,
Cool.
then like we
That
might
makes
call
sense
that
to me.
plagiarism
All right,
or something. Like
that's
that.
all I have. Thank you for your time. I guess quickly, do you have any questions, I guess, for me or any
Awesome.
questions about these prompts before I head off?
Okay, so note to the audience that in a normal interview, this would be a time when I would dive deeper and ask questions about, Keith's work or what, he enjoys about the company. And if I, find something in one of his answers that I'm really interested in, I'll dive into that a little bit more. But because this is just a fake interview and I don't really have any questions about Keith's company because the company doesn't exist.
Yep, that makes sense to me. And I
I
did
will
not
just
give
say
you
no
any context
questions.
really to work with here. So we don't have to repeat what we did with the video that posted on my channel. But cool, nice work. We can end interview. Switch gears.
Yeah.
Yep.
All right. So now let's switch over to the feedback session. Do you want to go through your notes and kind of just share what was good, what was bad, your overall impression?
I think this was an interesting session because I wanted to squeeze as much as possible into this. Like oftentimes you might see like a smaller, fully object-oriented design or a smaller, only algorithms, but I kind of wanted to get both because ultimately, from my perspective as an interviewer, I feel like having both concepts is how I actually evaluate your programming skills because a single algorithm doesn't tell me that much as far as your actual talents and if you'd be a productive member of our team. And also the object-oriented design might not say everything either. So I liked the combination, but it was a bit it is a lot of information. So feedback-wise, let's start with object-oriented design. I think solid overall. I think that you hit the key points.
Yeah.
I think some of the things that I'm thinking about with regards to your solution is you hit all of the key things that I was looking for. So all books in library, remember active book, remember last page in all books, display a page in active book. I think you did a good job with the basic class structure to capture all of that. I think what I would have liked to see if I was to be nitpicky and looking for even better solutions is I might look for even further breakdown of classes. So I think there was some things that could have been broken down further where I think maybe you could have a display class even that could kind of separate the details. You have the book class that has the title, the content, but then the display class can handle the font sizes, the characters per page, all of that, and just isolate that functionality. So that was one thing that I picked up on is just I think that it's tricky in an interview setting, but I think that to isolate different components and make it easier to fit all together, I think further breakdown of these classes could have been beneficial. And then my other kind of nitpicky comment in criticism would be I think the way that the IDs were structured wasn't necessarily the most easy to understand. So I guess providing some more details on adding robustness to these IDs. I think one thing that would have been interesting, I guess I didn't ask about this specifically, but the concept of okay, how could you then maybe if you only had a title in the book contents, how could you maybe grab that ID retroactively, or would you want to do that? So maybe some more robustness in how the IDs were set up, so that you didn't have to know the system to necessarily get an ID. Does that make sense?
Yeah, for sure. I definitely think that the ID part was one thing where it was
Yeah.
Like, I would have rather just used the title of the book or, like, some combination of, like, the title and author. And I think, like, for example, at, like, an actual library, they have, like, their code or whatever, and they have their system for, you know, if it's fiction or whatever genre it is, and then, like, some combination of, I think, author that I don't really remember. That they use to ID books, and I think that probably would have been like a better solution is if we had like the title and author and
it is tricky because you don't have access to that nice library. I think the key thing that you did well with the IDs is that you knew that had to be unique. You didn't want to have collisions, and by mentioning like titles might have collisions, that's super important because that would cause all sorts of headaches for us. Let me see what else I wrote down. I mean, again, like I'll reiterate, like this was a good solution. This was a solid solution. This would be like something I'm looking for. So like my feedback is more nitpicky and like how could things be improved further. I think another way, and this is kind of similar to breaking things out from, you know, a book class and then a display class to actually put that onto our Kindle Cloud Reader. But I think another way you could have maybe broke this down in a logical manner was when I asked that last follow-up question, which was basically, you know, you might have many users in this, and now we need to be able to, each user needs to have their own like last page for each book and all of that. I think that your answer could have been a bit more nuanced there. I think one thing that you could have maybe mentioned is we could have potentially used like superclassing, subclassing to maybe have like, you know, a base book class, but maybe there was like a user book class that built off of that class book that, you know, everyone shared ID, everyone shared title, everyone shared content, but all of those user specific things could have reused some of that previous code, but built off of it. So that would have been an interesting idea too.
Yeah.
That's all I have for the
for
object-oriented portion. Any, I guess, other comments on that section? Cool. And then I think for algorithm solution, I think throughout the interview you did a good job of explaining your thoughts. Super, super important to anyone listening to this. Don't just write something down. Talk through what you're writing down as you're writing it. That helps me make sure that I know what you're talking about. That makes sure that I know that you're on the right track or off track. So you did a good job both in the object-oriented design as well as the algorithm, just explaining what you were thinking and the pros and cons. So like one thing I liked in the algorithm section is, you know, coming up with a very naive solution to start. I like seeing that kind of iterative approach, see that you're kind of working towards more optimal solutions. So I liked the idea of using like every single substring in these two, but then realizing this is not optimal. I liked then you kind of building and taking that and being like, okay, maybe that's not the best approach, but let's take a base sentence and a new sentence and start going character by character in the base sentence and compare it to the comparison sentence. I think that was you're working towards a better solution. It's going to be better than that every substring approach, but still not quite optimal, and kind of realizing that there was more improvements that could be made. There was a challenge in how to get to the dynamic programming solution. I think we maybe lost some of those details you would normally have included on like the nuance of this and how you might improve it. So like I would have also liked to hear mention not only of verb tense, but also like punctuation if we have to keep that in mind. So if someone changed periods to exclamation points, should those still match or should they not match? All of that. And then just kind of getting to the dynamic programming. I think this was definitely like a challenge trying to figure out how to formulate this. So I definitely had to help a bit more. I think in an optimal, like perfect run through, you would have gotten a little bit further without me having to prod. But I think the nature of dynamic programming is unless you're reviewing it and like really like studying it and staying on top of it, like in the real world, you don't have to know this type of stuff. You're not coming up and like designing from scratch dynamic programming. You're usually looking at notes and all of that. So like I was, I'm okay in an interview setting having to prod a bit, but that's I guess a difference between a good interview and a perfect interview is like the nature is I had to provide a decent amount of details and kind of help you get to a recurrence. And then once I gave you that starting point, the launching point of the recurrence, you did a great job running with it. That was definitely like the optimal longest common subsequence or substring type of solution with recursion and memoization to help get us to the optimal. So it was nice to see that once you had an idea of what we needed to do, that you were able to run with it and knew exactly, where you could implement an optimal solution. I think that's all I have. I'm rambling on a bit, but hopefully those notes make sense, and I think we can further discuss.
Yeah, I definitely think that this longest substring was a slightly more challenging problem based on like, the problems I've done on LeetCode or like the ones that I faced in like actual coding interviews. But that's not to say that it's not like a good problem, right? I think it's a really good problem to ask and to kind of figure out, what are my strengths and weaknesses. And I think that one thing that, you probably learned from this is that, okay, maybe I have certain ideas that are there and that I like needed a little push in trying to formulate it properly. But then once you gave me just like a structure to formulate it, then I was able to take that and be able to run with it, right? Which I think that, from an interviewer's standpoint, like when you're interviewing, it's not just about can they do it or not. It's also about how would they, what would an interaction with this person look like, right? And so actually one thing that I really liked about this was that it seemed to be pretty collaborative and it seemed to be very casual rather than like me taking a test. And so, what that tells me as somebody interviewing is, oh yeah, like if I do get stuck, like this person would be able to give me a hint and then I would be able to take that hint and do the rest of the problem. So yeah, I mean, I do wish that I was able to just get that and formulate it, but I think that also dynamic programming is typically tricky like that, and it just takes practice kind of to kind of drill
definitely.
that in.
And I think that you make a good point where it's like, this was definitely, the dynamic programming question was a hard question. And I think sometimes once you feel like you're off track in an interview or like, oh shoot, I don't know the answer to this, like I'm screwed, I think realize that you might be purposely given a hard question because then you can identify a larger range of candidates. So like, maybe the tippy top is like, it's instinctual for them to like realize how to solve this with dynamic programming. But I'd say like the strong half of this, they won't know it right away, but they'll be able to work themselves to it. So like, don't get too flustered. This is not to you, this is to a general comment to anyone listening. Don't get too flustered by like getting stuck. You're oftentimes expected to get stuck. You're human, so you're going to get stuck. It's how you rebounded, and I think you did a good job mentioning, you rebounded well, and that's what's important still, like a very strong interview because you were able to work to the solution, and it was a hard problem.
Yeah. I will also mention, I think one other thing that a lot of interviewers do tend to look for is probably testing. So I do think that, it's a good signal. We were running out of time, but I think for the interviewer, it's a good signal if the interviewee brings up testing and says, oh, like, I like the solution, but in order to verify my answer, I would like to test it or I'd like to run it or something like that. And I think in terms of what the interviewer is looking for is that they want to see that you're going to be a good software engineer, right? And I think testing is a big part of that equation. And so I think that just mentioning maybe, hey, like these are a few cases that I would have ran through if I had extra time, or, here are some of the edge cases. Like I think this might work for most cases, but there might be some sort of edge case here and there that I should have like gone through. I think those would be
that's a great point.
That should also be a component that you mentioned.
The testing is super important, so seeing that, and it is challenging because we did kind of run out of time. So like I feel like you didn't hit some of those things that you probably would have hit if we had all the time in the world. One thing that's interesting, I saw this on Twitter or LinkedIn as an idea. I don't know what your thoughts are on it. I think that it is a pretty solid idea. I would kind of be impressed if a candidate did this, but I could see it going either way. Someone mentioned they were like a data analyst at Google, And in the interview process, like they screwed up, I think, a couple queries, SQL queries. And after the interview, they like, calmed down, like they collected their thoughts, and they like emailed the interviewer like the solutions, like, oh, like I goofed up there. This is how I would have solved it if I, had a little bit more time. They followed up with like some solutions. So it'd be interesting. I don't know if you think it would be a good idea or a bad idea. I could see it going over either way, but to like follow up and be like, oh, I didn't get to mention these testing cases. This is what I would have done. I think it's probably situation specific because it could be kind of weird too. I don't know. I'm just throwing that out there as an interesting avenue if you feel like you wanted to redeem a bad interview or something like that and like have some saving grace.
Yeah. Well, I definitely do think that is like, I don't think it's necessarily, I don't think it would be a bad idea under any circumstance. I think that, okay, maybe your interviewer would never see that and they find it a little bit strange, or maybe they've already submitted their whatever, but I don't think it can hurt. And if anything, I think it shows dedication, and it shows that, you couldn't solve this problem, but you took time and you thought about it some more and you didn't give up, and then you did come up with the right solution and you followed up and communicated that.
Yeah. I think it's situation dependent. If I feel like my interview went great, I probably wouldn't feel like the need to do that. But if I feel like, oh shoot, that was like, I'm so much better than that. At that point, it can't hurt to do something like that and just keep it casual. Keep it like, hey, I thought of this. Thanks again for your time.
Yeah.
Take care. Like.
Okay, so now after the interview, I just wanted to follow up with you guys. That interview, if I walked away from it, I would have been like, all right, well, there are certain aspects that, just like Keith said, there are certain aspects that signaled, I was probably a strong candidate, but I personally would have walked away from that being like, dang, there are some parts that I probably could have done better on. Like, I needed his help a little bit. I probably could have, eventually gotten it if I just had a bit more time to think, or maybe today was just not my day. And that's just sometimes how these interviews go. You can't do perfectly on all of them. Now, a few notes about my implementation specifically. I use pseudocode because Keith, the interviewer, specifically said it was okay to. And in this specific problem, I really wanted to focus on the algorithm and not really kind of get into the syntax of things. And so for me, Python is almost basically pseudocode, so most of it was very Pythonic. But I commented all out because I was too lazy to get that max part working, because I wrote like possibility 3 if applicable, and I was just a little bit too lazy to like actually implement that. And then also there was some underlining that just wouldn't go away, and that was really bothering me, so that's why I also just turned it to an entire comment. Now, some things to remember about interviewing in general. So don't be scared to ask questions. Turn the interview more into a conversation, because that also gives the interviewer a signal of, this is what I'm like as a teammate. This is what it's going to feel like when you're working with me. Now, during the interview, I would always recommend repeating the question to the interviewer, just so that you can check if you actually understood the question, and then from there maybe even ask clarifying questions. And I typically start with something known as the naive solution, which is this is the first thing that I thought of, and this solution would work, but it's kind of this very brute force solution where it might take a lot of time and it might not work. I might time out for these super long strings, or these super long data files, or this very large array, or something like that. So it's very, very unoptimal, but it is a solution. And then from there, that's when I start brainstorming, okay, well, this sucks in terms of timing, so let's figure out how we can optimize it so that we can make it run faster. And from there, if you can find the optimal solution, then you implement it the best way and you are good to go. All right, thank you guys for watching today. Best of luck if any of you have software interviews coming up. Be confident.